Alright, today we are looking at the characteristics of quadratic functions, also called the parts of a graph. So we have a lot of different parts of the quadratic functions, and it's important to know how to label these. So the first one that we're looking at is the domain. And with quadratics, looking at the domain, you're always going to want to look at the x-axis. This is talking about left to right where the graph falls. So I always add in arrows because a quadratic function extends to infinity. Even if it opens in the other direction, it always has arrows on the two ends. So the domain for a quadratic function is looking at the x-axis. From where to where does it fall on the x? Well, if it keeps extending and gets wider and wider, it's going to go all the way to negative infinity to positive infinity. And that will be the case with every quadratic function, even one that has a maximum point and opens down. The next thing we're looking at is the range, and the range is looking at the y-axis, bottom to top, where does the graph fall. So it doesn't necessarily mean where does the graph touch the y-axis. That's going to be your y-intercept, which this does ask us about the y-intercept. That's where it crosses the y-axis. The range is where does it fall from what y values to what y values, starting at the bottom, always at the bottom. So at the bottom, this graph starts at 0 on the y-axis. So we're going to have a bracket on 0, and then it'll point up to positive infinity, and we have a parentheses on the infinity. Now the reason we use the bracket is because that this 0 is going to be a part of our vertex. It's a part of the graph. That means it's included on the graph. You always use a parenthesis for the infinities. So again, the vertex, that's going to be the lowest or highest point. And in this case, it's the lowest, so it's a minimum. And it's going to be at 0, positive 2. Or at 2, 0. Alright, so interval of increase and decrease, this is always going to be listed by x values, and we go left to right. If I trace it with my pen on the left hand side, I have a negative slope, my pen goes down. That's going to be the interval of decrease on the left hand side. So from where to where on the x-axis does it decrease? So it's going to point left to all the negative x's and then go to 2. So your decreasing is negative infinity to positive 2, and we always use parentheses on the intervals of increase and decrease because we can't say at point 2 the graph is decreasing. Well, at point 2 it's just a point. So that's why we use a parenthesis. And again, although it's pointed up, it's pointed left. We're listing this by x values, it's pointed left to negatives on the x value. So the increase will be the right hand side where you have a positive slope, or where your pen moves up. From where to where on the x? That's going to be from positive 2 to positive infinity, because this arrow will keep extending out further and further right, and the x's get more and more positive the further right it goes. Alright, axis of symmetry is always the first value of the vertex. So that will be x equals positive 2, and you always write that as an x equals line. That's where if you graphed it and folded your paper in half, the graph would be perfectly symmetric about itself. Alright, end behavior. End behavior deals with the quadrants the ends are in, going from left to right. So let's go ahead and write down left for this end and then right on this side. So the left end is in quadrant 2. The signs in quadrant 2 are negative, positive. The x's in quadrant 2 are negative and the y's are positive. So then I go over here and put negative. They filled in the first one for you. Negative infinity, then positive infinity. Then the right end, this end behavior, is in quadrant 1. In quadrant 1, your signs are positive, positive. So you go down here and fill in positive, positive. Sometimes the first one will be filled in for you, sometimes it won't. And then lastly, where does it cross the x-axis? That's your x-intercept. And where does it cross the y-axis? That's your y-intercept. So the x's, that's going to be at 2, 0. And then it crosses your y-axis at positive 4. So lots of different parts here. Let's look at another, number 2. And please notice the difference in number 1 is that number 1 has a minimum and it opens up. Number 2 has a maximum point and it opens down. So I always like to start at the vertex. This one is a little tricky because we have some decimals here. So for this one, it looks like our vertex is going to be at 2.5, comma, positive 6.5. The axis of symmetry is always the first value in the vertex, and it's always an x equals equation. And remember, that's if you drew a dotted line there and folded your graph in half, it would perfectly map onto itself because it'd be symmetric about the vertical line. Alright, then I fill in my domain, which we should never miss. That's negative infinity to positive infinity for every quadratic, even if it opens down, because it still has arrows on the ends and will go out and out in both directions to the negative x's and the positive x's. Even if we're way down here, as we extend, if we go way down here, the x's are still getting more positive on this side. Range, remember the range, we're looking at the y-axis. The range is the bottom to top. So looking at the bottom, we see arrows at the bottom pointing down, so the arrows will go to negative infinity. And then the highest y value is 6.5, and we put a bracket on that for the range. The range is the only thing that will have a bracket. Then we have our intervals of increase and decrease. Those are going to be your x-axis, and I trace it with my pen. So over here on the left-hand side, my pen is moving up. The slope is positive. That's an increase interval. And then I ask myself from where to where on the x-axis. Well, it's pointed down, but really it's going to keep extending out this way to the negative x's. So your interval of increase is going to be negative infinity to 2.5. Because at 2.5 here on the x, remember we always list intervals of increase and decrease by x-axis. That's why I didn't put 6.5. So at 2.5, now the graph starts to decrease. So my decreasing interval starts at 2.5, and it's going to go to positive infinity because although it's pointed down, again, down would be looking at the y-axis. We're looking at it pointed out. It'll get more and more positive the further out it goes on the x. So interval of decrease goes from 2.5 to positive infinity. You just have to train your brain to look at the correct axis. This one has a maximum point, and that's just going to be where the vertex is. The maximum is at 6.5. Or you can write the whole ordered pair like I did on number 1. And behavior deals with the quadrants. So this one we want to look at where will the ends go? Where will they end up? So the left end will end up in quadrant 3, and the signs in quadrant 3 are negative x's and negative y's. So I go over here and I fill in negative infinity, negative infinity. Then the right end is over here in quadrant 4. The signs in quadrant 4 are positive x's, negative y's, so I fill in positive infinity and then negative infinity for the end behavior. Think quadrants for these. You might have to extend the ends to figure out which quadrant they'll end up in at the very end. X-intercepts, where does the graph cross the x-axis? This one's going to be at 1 and 4. Y-intercept is where does it cross the y-axis? Well, we don't have that here. It doesn't touch at all on this picture, so you can just write none. There's your example for number 2. Go ahead and try the rest of the sheet and then check your answers online.